Hello, this is Dr. Oz. In this video, I would like to show you how to calculate objective function for capacitated plant location problem. This is part two. In part one, we defined the objective as maximize the profit. And also we defined the decision variables as shipments from each of these 13 countries to each of these 13 demand locations. And also another decision variable here is whether we should keep them open or close those locations, and we calculate these constraints where shipments from should be less than or equal to the plant capacities in those countries. And also demand, we can up to sell up to those demand amounts that are given in the problem. And also we would like to be in one of those three countries, India, Mexico, or Turkey, not all, but one of them at least, and at most one. So exactly one, in other words. And then we don't want to penetrate into more than 5 countries out of 13. That's why it's a less than or equal to constraint. Now, I would like to work on how to calculate the objective function. So to be able to do this, first of all, I would like to look at these production locations. Control C, Control V. These are our production locations. And then I would like to calculate um, revenue values for each of these locations. And I will calculate the costs, including the fixed cost and variable cost. And also what I would like to do is calculate the net income before tax values, as well as I would like to calculate the tax values. Finally, I would like to calculate the net income values. Perfect. So let's start with revenues. So in Australia, I would like to multiply the revenue per unit, which is $100, times, I would like to multiply all the shipments out of Australia. So right here, row sum, as you remember from part one, video part one, is right here. So I would like to drag this formula down. To be able to do that, I need to lock my blue cell, which is $100 per unit revenue. Click on it, function F4. And then these are revenues, so I would just make them dollars, and I don't need decimals, decrease decimals right here. And right down corner, black cross, double click. That's how we calculate revenues for every single production location. Now let's take a look at the fixed costs. And here, the fixed costs are a little bit tricky because we need to look at the fixed cost amount for a given country. That's Australia, right here. However, we only have to pay for this cost if we keep that facility open. So I need to multiply that by open close decision associated with Australia. And right hand corner, black cross, double click. And as you can see here, this cost is 0 for everywhere except 2.4 because for fun, I just chose Turkey to be the only facility that's open. Okay. And another thing that's very related to fixed costs, if you go back to our constraint right here, you remember all these capacities? These capacities should be only activated if we decide to open those facilities. So for example, here we say that to Excel solver, we have 240,000 capacities, but that's not true because it's closed. Okay. To be able to update these values, I need to multiply the capacities by the corresponding open close variable decision. Then click on it, right down corner, drag it down. So you can see that right now I have only one capacity, which is Turkey, which is 60,000 if I only open this. So if I decide to open another facility, let's say Australia, now I have additional capacity there to 240,000. Perfect. And obviously that will increase my fixed costs as well. So the variable cost in this case is transportation costs on those edges between nodes. So I will use here the some product of all the shipments from Australia to all these 13 countries, comma, their corresponding costs. Australia to all these 13 countries. So you can see that, let's see, we made a mistake because you can see here, it should go all the way to United States. When you see this kind of arrow, you can just expand it. And that cost right here, again, these are cost numbers. So I will just highlight this area right here and click on under Home tab dollar. And I don't need decimals, so I will decrease decimals twice. So here I can drag this formula down, right down corner, black cross, double click. Now I can calculate net income before tax, which is nothing more than revenue minus expenses. And right down corner, black cross, double click, you can see the um, all these values here in terms of revenue and fixed costs and variable costs and so on. But here, another issue that you may observe where I'm trying to ship stuff from Canada. However, Canada facility is closed. Why? Because again, you see zero. So that's why actually our revenue also should be only activated if the facility is open. So I will update the revenue column as well by multiplying Australia by Australia open close decision. And then click on the 300 again, right down corner, black cross, double click. Perfect. So now what I would like to do is calculate tax amounts. It's nothing more than net income before tax times the corresponding tax rate for a given country. In this case, Australia 30%. And click on that right down corner, black cross, double click. Perfect. Again, this is another thing, right? So variable costs also should be only incurred if the facility is open. So some products of these values times, right, times open close decision for Australia. And then click on it, right down corner, black cross, double click. So I should not have any variable cost if I don't make any shipments. If I cannot make any shipments anyway if I don't open that facility. That's good. So now I can calculate net income values. Basically, it is nothing more than net income before tax minus tax amounts. And if you click on it, right down corner, black cross, double click. So now we calculate those values. Okay, finally, we can calculate our objective function value, which is the sum of all those net income values that we generate in each of our facilities. Currently, we are losing $2.7 million. And then file, options, add-ins. Make sure that you click on analysis toolpack, Excel add-ins go, make sure solver add-ins checked, click OK, and then go to data tab, solver, and add the objective, right? You click on this little icon and the green cell, enter. And I would like to maximize profit, so max, and click on this little icon right here. And these values are decision variables, enter. And now I need to add the constraints. First set of constraints is make sure that these decision variables are binary, bin, add. And also, we would like to make sure that these values, shipments to values, should be less than or equal to the demand values, add. And also these left-hand side shipment from values are less than or equal to the capacities, add. And also we would like to make sure that this decision variable, and the constraint I should say, left-hand side should be equal to 1, add. And finally, this value should be less than or equal to this value right there. Click OK. So you can see all the constraints. I want to make sure that all my yellow cells decision variables are non-negative. and we are using linear programming and solve. Okay. So now looks like the linearity conditions are required by LP solver are not satisfied. So that's the issue that we are getting. So basically Excel is saying that something in this model is not linear. So let's take a look at it, what that can be. So here, some of those values, that should be all right. And net income values, they should be all right. And tax values are good. Here, I think everything is linear. Uh, Here we have some product of all those values. Okay, perfect. Just want to make sure that we are not creating nonlinear relationship. But here we multiply variables with variables, right? That's the issue. So then, right? I mean, that's perfectly fine. Why don't we just delete this? Because we don't really need that. It's not wrong, but it's just if you multiply variable by variable, that will create a nonlinearity issue. And then click on it, right down corner, black cross, double click. And then same thing for, let's see, revenue is good because this is a variable versus this is a coefficient. That's fine. Same situation is observed in revenue where I need to delete the open close decision for the revenue because again, I don't want to multiply with variable with by variable. That will create nonlinearity issue if I want to use solver. So you may say, okay, Oz, this shouldn't happen. Yes, that's right. However, we will regulate that by capacity constraints anyway, right? So solver will take care of it. So that's why, even though that sounds logical, don't worry about it because Excel solver will force to close some of those facilities. And if it's closed, Excel solver will not allow to make shipments from those locations by these constraints right there. So now if I just rerun the problem to see whether we can solve the problem. Okay, perfect. And the best solution for this problem is um, 40 around $42 million by sending 30,000 units from Australia to Australia, 210,000 units from Australia to Japan. I will give you a couple more examples, not all of them necessarily. You can see them all. 300,000 units from Italy to Poland, etc. And you can see that we decide to open some of these facilities, not all. We decide to open Australia and France and India and Italy and Japan. That's all. And let's see whether these constraints are satisfied. So all the shipments are non-negative. That's good. All the open close decisions are 0, 1. That's good. All these left-hand side values are less than or equal to the right-hand side values. That's perfect. And I zoom in a little bit. All these left-hand side values are also less than or equal to their corresponding right-hand side values. That's good. As you can see, some of demand is not satisfied because we don't have enough capacity or other constraints are forcing us to not do that. Like for example, we open only one of these countries, India, Mexico, Turkey. Let's see which one we did. Um, so if you look at it, I think Mexico, right? Let's see. Yeah, no, not Mexico is close. India, yes, India is open. So out of these countries, 3 countries, we decide to open India, and 5 countries are only operating. And you can see that if a country is not open, we don't generate revenue, we don't generate variable costs, and so the best solutions again right here. I hope this you enjoy this video. Until next video, enjoy business analytics.